So how are we doing that? What's our plan? So Sam, put that. Don't worry about that for right now. Like, stay with me for a second so that I know you understand the theory. How are we going to measure it? You're going to snap and time. So you're finding a time. And what time are you finding?
The snap, the first echo to the second echo.
Okay. So if we draw our tube, so here's our tube, and you may want to draw this too, just so that you've got it and it makes sense to you. So here's your tube. Oh, you can't see any of this? Oh, there's my tube. Isn't it cute? I'm sorry. There you go. So you snap. And what does that do? What does that sound do? Before it bounces, what does it do? It travels. It goes down, doesn't it? It goes down the tube, and then when it gets to the bottom, what does it do? Words? It bounces back up. So it travels back up this way. And that red asterisk represents this time right here. Does that make sense? Okay? And the microphone that is sitting right there hears that first snap, and then it hears that next thing, that when it comes back up, that's the first echo. Okay? That's right here. Does that make sense? Okay? And then what happens maybe again? What does the sound do? It travels again, doesn't it? It's going to go back down. And then what does it do? It comes back up. And then we hear it one more time. And that's the third echo. Or the second echo, the third thing. Okay? So now you know times, right? Do I actually want the time when this happened? Leanne's shaking her head. Why no?
You want the time between.
Right. I want the time between here and here. So I'm going to use my skills of subtraction to find out how much time happened between here and here. Right? I'm going to use my skills of subtraction again to figure out how much time there is between here and here. And hopefully these are about the same. Right? That's our goal. So, and any time that I do that same tube, the tube that's this length, I should have about the same delta T. So if I did 2 trials or 3 trials or whatever, every single time my delta T should be the same. Okay? So when you write your times down, you're writing down the time of the snap and the time of the first echo and the time of the second echo. But the thing we really care about is that delta T. Okay? So you're going to get a bunch of delta T's for the long tube. Okay, so I've got my time. Yay for me. I got my delta T. But I don't want to know delta T. I want to know the speed. How do I find the speed? How do you find the speed of a wave in this case? Distance over time, right? Just like we did in September. Right? We rolled that bowling ball down the hallway. You remember this? Or basketball. We didn't have the bowling ball yet. Right? And down the hall it went. Rolly, 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 rolly. Velocity is distance over time. So now we've got the time. How far does it go between the time when I snap my fingers and the time when that blue asterisk happens? How far does it go?
The length of your tube.
The length of the tube. Do you guys agree? Does anybody disagree?
Wait, so what's the distance from here?
That's what I'm
to
asking.
here?
That's what I'm asking.
So
Isaac is saying it's the length of the tube. Do you agree with that? You're saying that length, right?
Yeah.
Times 2.
Why times 2?
Because it goes down and
Because it goes down and back
back up.
up.
Yeah.
So the distance that it travels is actually 2 of the length. Okay, so you know that time, and you're going to do that 2L divided by that delta T. This is going to tell you the speed of sound. The speed of that wave as it travels down the tube and back up. Okay, is that making sense? So you're going to get a bunch of delta T's and probably, I don't know, average them together to get 1 delta T for your long tube. And then you're going to do it a bunch of times and get 1 delta T for your small tube. You got two different lengths. And so you should get two values for velocity. And then when you go down to the bottom here, you found an experimental value, right? So you found what this thing is. But we want to know what the theoretical value is. The speed of sound in air it varies depending on the temperature. It's not like the speed of light. So that means you're going to need to do a little bit of thinking. Use a thermometer to find the air temperature. There's a thermometer up here you're welcome to borrow. Okay? And then you're going to calculate the percent error between what you got from your snapping tube and what you get from doing the thermometer. Okay?
So.
Go ahead.
A total of 2 delta T's for one trial.
2 delta T's. Or 3 or what do you mean for one trial?
So for one trial, you're going to get the snap, the echo 1, echo 2, and between the echo 1, echo 2, and between the snap and the echo 1, that's 2 delta T's.
That's going to be 2 delta T's. Yep. So if you do it a couple times, you might have 4 delta T's.
Okay.
Yeah.
So then label that as trial 1 delta.
Sure.
Okay.
Yeah. Yeah. All right. Is this making sense?
Yeah.
Okay. So what I would like to do, I'm just kind of keeping an eye on the time and keeping an eye on what we need to do. I'm going to give you another 5 minutes. And in those 5 minutes, the thing that you need to get done is to get your values, your times. Like that's what has to be done. Okay. Because you can't do that outside of class. Everything else you should be able to do outside of class now. Does that make sense?
This is doable.
Monday. But yes.
Oh, yeah.
Yeah. Sound good? All right, I'll give you 5 more minutes, and then we're going to regroup with our wave words.
I'm gonna try to.